Okay, so in the last slides we discussed energy transfers and defined fluxes. So they are all coming from nonlinear terms. Okay. Now we can use these ideas, also earlier ideas done by various researchers, to talk about energy turbulence models for MHD. The Kolmogorov model is great for hydro. It is very good as long as we force at large scales. Of course, we need modification if the energy is injected at different scales, and that was generalized for buoyancy driven flows. So we see in MHD what kind of generalized models exist, but at the outset I say that there are still unsolved problems. There is no convergence, though I am a believer of some theory, which I am a strong believer, but there is no convergence among everybody. Does not say, well, this is the correct model. There is no one correct model because there are large number of variables and so on, but there is still a lot of divergences. So one thing I can say at the outset, that is not a passive vector. So phi third is not expected really, because there is FV and FU which are active, so they can change the fluxes. So we cannot use phi third theory ideally. So we will have to argue from different angles, and we have to do that. So in this slides, I will present some leading models which are 50-year-old models, some are 30-year-old models. So I will just present them very sketchily. So first model is by Kreknin and Ryzhnikov model. Kreknin's paper is one-page paper in 1965, Physics of Fluids. It's just one-page paper. That's why it is, I think it has been misinterpreted and is hugely cited, but it is incorrect. Okay. So what does Kreknin say? So according to Kreknin, there is a mean magnetic field, and that leads to alpha n waves, right. So we discuss alpha n waves. So that's why alpha n wave is a key for modeling MHD turbulence. So remember, so let's assume that B naught is in this direction and alpha n waves travel, and there are two types of alpha n waves, Z plus and Z minus, and one of them travel, in fact they travel in opposite direction. So one with UB in opposite direction travel in along B naught, and one with UB parallel travel along U minus. So Z plus should travel backward in minus B naught, or minus B naught cos theta. It need not be in the same direction. Okay, so these is one page paper, so there is huge amount of hand waving. There is slight of approximations, and but the ideas are kind of interesting. So there are two waves or two packets going in the opposite direction. So they will interact briefly, according to Kreknin. Okay, and what is the time scale for interaction? So length scale is L. We will come from wave number, and the velocity is V naught cos theta, but there is one model which tries to model cos theta as well, but let us assume that we ignore theta effects. So L by B naught will give you the time scale, right, from dimensional arguments. The time scale for a wave number k will be 1 by k B naught, and B naught is a constant. Okay. Remember, for Kolmogorov, what is the time scale? Kolmogorov theory, tau k is Kolmogorov hydro. Now, please remember this. So L by UK, UL. So 1 by K, UK. And what is UK in Kolmogorov theory? Epsilon 1/3, K minus 1/3. Okay, this comes from dimensional arguments. From phi third you can easily derive this, which I have done in the class. So this will give you K2. So this is K dependent, and in Kreknin theory is K independent because of alpha n effects. So B naught cannot be, B naught effects are real. What about U naught? Can somebody may say, well, if I apply wind velocity field for hydrodynamic turbulence, then I should get similar features, right? Why isn't the time scale 1 by k U naught? for hydro. Okay. So, it turns out velocity field can be eliminated by Galilean transformation. No, we can go to a frame where u naught is 0, but we cannot go to a frame where b naught is 0. B naught cannot be gotten rid of. Okay, so that cannot be gotten rid of by Galilean transformation. So these effects exist and they are real. Now we can do dimensional analysis, which I will not do it here. There is a nice paper by Dobrovolny et al. In 1980, I think, so around that, and there it is derived in more systematic manner, a Krecknen idea, because it is one page paper. So in this theory, it has been argued, so the z plus and z minus are basic variables. So I am basically stating Dobrovolny's result, but the Irishnikov paper also a very short paper, a similar idea. So that is why I call Krecknen and Irishnikov, Russian and American, 1965. So in this theory, pi plus a flux of z plus approximately equal to pi minus, and that goes as they are approximately equal. Okay, and so we can write, well, I mean there is a formula for in terms of E plus k, E minus k. So it is a product of E plus and E minus. This generalization by Dobrovolny. Krecknen assumed that E plus equal to E minus, but it need not be equal, they are other unequal. This is a B naught below and k cube. Okay. So this is proved by Dobrovolny. Now if you assume E plus, so one thing you can see that if E plus and E minus are not equal, it could be any number, it is a product, but the fluxes are equal, right. So fluxes pi plus and pi minus are always equal irrespective of ratio of E plus and E minus. This is a prediction of this phenomenology. Okay, the proof I am not giving you, I mean these are bit detailed proofs. Now let us take a special case when E plus equal to E minus, then what happens? E plus k both are equal, so I can write down equal to E minus k. So B naught will go there, B naught pi square root, right, because there is a square, k minus 3/2. This is a theory of Krecknen and Irishnikov. So it is not 5/3, it is minus 3/2. Okay. So there is a difference in exponent, but the numbers are quite close, 1.5 and 1.67. Now let us go to, so this is old theory and people believed it very strongly. So there is a paper by Marsh in 1989 and it says the following, says, well, let us ignore the B naught effect. Okay, so you can assume the B naught is 0 or some of it is just trial and error, just let us ignore B naught effect. If you ignore the B naught effect, then we have z plus dot is z minus dot z plus, right. These are our term. Now for scaling arguments you do not keep all the terms, you keep only this. So if I look at the fluxes, what happens? I multiply by z plus both sides. So this left hand side is like flux. You can also argue from what the flux we derived, okay, but this is easier done by dynamics. So this is pi plus under steady state, you can put a force in the right side and this pi plus, and this one is grad will give you k, z minus give you z minus k, z plus k squared. Now what is z plus k squared? E plus k times k, is that correct? This is a definition of what is E plus k. is z plus square divided by k. dk is k, right? I mean that is what we said is power law of physics. So, dk is k. So, it is a real space. So, there is no star. No, so, unless you have to put a star, in fact, is true. But I am doing estimating, this is scaling argument. So, you are doing a real space. So, by the way, Kolmogorov theory can be derived exactly in the same manner. Okay, so from here I am going to real space, a Fourier space. So, here I assume local approximation, local interactions. So, modes of similar sizes are interacting. So, first equation is in real space, second equation is a Fourier space. So, let us write this as k, e plus k, k, and the other one will be square root of e minus k times k. So, the second term is z minus square root. So, the asymmetry in e plus and e minus. So, if I, so this equation for pi plus, pi minus will be a similar equation with plus minus interchange. So, if you work out for e plus and e minus, invert it, you get the following: pi plus 4/3, pi minus 2/3, k minus 5/3. There is a constant k plus. So, you get 5/3 law, but there are two fluxes, pi plus and pi minus. Okay, this for pi plus, e plus, and you can get equation for e minus as well, right. So, what will happen for e minus? Just replace plus and minus. Now, you can also derive e plus by e minus is pi. So, 5/3 will cancel. So, pi plus by pi minus square k plus by k minus. So, here if e plus and e minus are not equal, then pi plus and pi minus are also not equal if they are connected by square. So, this relation differs from Kretkine-Rezhnikov, where pi plus and pi minus are equal. Okay. So, this is a second phenomenology given by Marsh in 1989. Now, it looks kind of odd, no, that we have 5/3 and 3/2, which of them is correct? So, this 5/3 and this other one is 3/2, which is correct? So, that is where I come. So, I said let us try to understand this. This bothered me it still bothers me. So, this intuitive idea is a mean magnetic field B naught, and there are alpha n waves of various scales. So, if there is turbulence, so that means there will be alpha n waves of many scales, right. So, the B naught, there is a one big alpha n wave, there is smaller alpha n wave, smaller alpha n wave like this. They are traveling in all directions. Now, for this alpha n wave, does this see only this B naught, or does it see collective effect of all waves? It should be collective effect, right. I mean, so if you are trekking in the Himalayas or in a mountain, you are not looking at the mean slope of the mountain, local ups and downs. So, same way the waves should be seeing local mean magnetic fields. So, are you convinced with this? So, at least intuitively it seems possible that though there is a mean magnetic field effect, which will probably effect of the phase being changing, like B naught effect, but the nonlinear interaction, the local fields must also affect the alpha n waves. So, for these alpha n waves, what should matter is undulation here, and for these alpha n wave, what should matter is B coming from here, and so on. So, this procedure is addressed by a theory called renormalization group. Okay, so this is scale by scale theory. In fact, if you look at quantum electrodynamics, So, if you have seen this, you might have heard this, the bare charge of electron is infinity. Heard of this term or no? So, electron has infinite charge and infinite mass, but what we see is not infinite charge and infinite mass. Why do not we see this? Whether there is no single electron, this electron will create an electric field, electric field will create positive neutron pair because of Heisenberg answer. So, electric field will, if you quantize it, you will get various virtual particles, because virtual particles. No? So, electron is covered by this lots of particles which are being created. So, what we see is a single electron, or what we think is a single electron, is collection of a central electron plus lots of virtual particles. So, like there is a horse riding in a very dusty environment, so there is a lot of dust collected around the horse. So, that is the analogy some people make. So, there are a lot of virtual particles around it. So, if you go close to the electron, you are not going to the center of the electron, but you are seeing collective effect shielding of the infinite charge by this lot of virtual pairs. Am I making myself clear or not? So, what we are seeing are if collective effect. So, if a charge will increase, if you go closer and closer, you understand. So, log. So, what we are seeing is a charge at some scale. So, similarly here my magnetic field effects will change when I go to different scales. So, the B naught which is postulated by Krecknen is not a single constant B naught, is function of k. So, when I go to inertial, so if I make this wave number scale k, then I have small wave number here, you just see the mean magnetic field, large scale, not the mean magnetic field. If you keep going down, then you see effects of other fields, like we are going closer and closer to electron, the effects are changing of the shielding. Okay. So, this is solving the problem scale by scale, and we follow this procedure by Wilson, and you can show, by the way, this is a big calculation, it published in 1999. So, B naught is k dependent, and it is pi 1/3 k minus 1/3. Now, it is kind of nice, no? It is same as UK of Kolmogorov theory. Kolmogorov theory is pi 1/3 k minus 1/3. I wrote that. So, B naught what is affecting the waves nonlinearly is this. So, now if I use the formula for Krecknen, so what is Krecknen? Formula, Krecknen-Ereshnikov formula k minus 3/2. So, let us put this pi half, pi 1/3. So, B naught, let us put a B naught here, but I replace B naught of Krecknen by B naught k. Yes. So, that will give you, so inside, let us put inside. So, this pi and pi 1/3 will give you pi 4/3, right? Pi 4/3 k minus 1/3 here to the square root k minus 3/2. So, this will give pi 2/3 k minus 1/6, and 1/6 and 3/2 is 3/2 plus 1/6, 6, 9 plus 1, 10 by 6 is 5 by 3. Okay. So, we recover Kolmogorov theory by just replacing B naught by k dependent B naught, but here assume z plus and z minus are equal. If you make it unequal, then calculation is very complicated, which I try to do it, there is some work, but is more detailed. I am not confident of that calculation. But this calculation is reasonably correct and clear. So, this is how we make a consistent theory of Krecknen theory and phi thread theory, and show that mean magnetic field is not B naught, but it is a local mean magnetic field, and this is a word which is used quite often now in literature, local mean magnetic field, which is B naught k. Okay. So, this I would like to verify this numerically. Okay. This has not been done in a computer simulation. So, there are ways to measure B naught and we need to do it. Okay. So, we move on. So, the 3 models done. So, let us go to fourth one, Goldreich-Sridhar model, which is highly cited paper, but which is weaker than my B naught effect paper. But what this Goldreich-Sridhar says, if there is B naught, then it brings in anisotropy. It is true, I agree, B naught will give, but if you make it too strong B naught, then there are some more complications, and a very strong B naught will make it 2 dimensional. So, all this theory will just disappear. So, as soon as you bring in 2D, inverse cascade, all that thing comes. So, B naught you assume order 1, and then isotropy is reasonably good approximation. Okay. I do not know. So, this is where I think there are a lot of divergence. So, B naught effect, and this is a highly influential paper accepted by a lot of people. So, according to them, this is called critical balance. So, I am just stating them. Okay. So, I am not taking any side except my side of my B naught k. Okay. So, critical balance is k parallel B naught is k per z per k. So, this is a relation of the alpha n wave with B naught, also connecting k perp and k parallel. Now, this is a postulate. Some people argue against it, of course, many people believe it as well. Now, this also should be tested. If you put that, then you get different spectrum for k parallel and k parallel, k per. So, you get basically formula for E k per E k parallel. So, this is a formula with anisotropy, right, which is a good formula, but I mean these, some people claim that it has been verified, but I mean there are still issues, especially with very strong B naught. And now, if I just average over k parallel, integrate over k parallel, then you get again minus 5/3. The formula is a bit complicated. If you like, I can write that formula, but it is combining both. Okay, I do not know. I mean, you can look at this. There is a formula with k parallel, k perp, and is there in my notes. So it is here. Pi 2/3 k perp minus 10/3 g, which is a non, this g is a function, this is coming from here. If you put k perp, z perp is k perp minus 1/3, you will get this, right. Okay. So, because it is 5/3 z perp, so z perp will give you from here k parallel B naught k perp minus 1/3, no, 5/3 will give you that. So, this gives you k perp 2/3. So, this is exactly coming from here. Okay. So, this is a formula, from this you can derive 5/3 and various stuff, and this is paper is 1995, 1996. Okay. So, this is fourth model. There are quite a few more, I will skip. The paper by Galtier, there is a paper by Bolderev, but I will skip. Okay. There is an endless story, there are a lot of models. Now, let us look at structure function. Now, this is kind of nice. If you ignore the B naught effect, then you get 5/3. So, this is what is Kolmogorov theory, is minus 4/5 epsilon L. Now, here we get this S3 is an interesting combination of Z plus and Z minus. So, it is Z plus square delta Z minus. Take the component, parallel components. So, this is averaged, this is S3. So, it is a combination of Z plus and Z minus. So, Z minus is a mediator and Z plus and Z plus are receiver and giver. So, mediator is coming with power 1 and giver and receiver are coming together as power 2, and this is exactly the same as passive scalar formula which I discussed. So, the derivation is identical for passive scalar for this derivation, and this is by Politono and Fouquet. Okay, this is their paper. So, this is a bit later in 2000. You will find them in the book. Okay. So, this is 2000 something or 99, late 1990. So, this is telling us that structure function, of course, this B naught effect is not included in this, gives you phi third. If I go to spectrum, we expect phi third, I mean not quite derive it, but phi third. Now, so how to prove this? It turns out doing lab experiments, though some of it has been done, but very few, getting turbulent MHD is very difficult. The reason being that so eta is large, the diffusivity, so you need very large L. So, like solar wind, so this is one good setup which a lot of people, I mean including I was also, I mean I did little work on this. So, Supratik does a lot of work, and I think you may be doing some work. And Sun's atmosphere is not static. So, there is a Sun, so this was proved by Parker. Nobody believed him for many years means several decades, I think they did not believe it. So, he says Earth's atmosphere is not stationary like Sun's atmosphere like Earth. Earth has a stratified atmosphere, but nothing is blowing out of the Earth. But according to Parker, Sun is emitting electrons and protons in some helium from its atmosphere, and there is a wind blowing, and this is called solar wind, and its mean speed is around 500 kilometer per second, huge speed, no, 500 kilometer per second. Of course, it ranges from 200 to 1000. There is a lot of variations, but it is huge speed, and the density of this plasma is how much? Is very rarefied, is 5 particles, 5 protons per cubic centimeter, is very, very rarefied. Okay, I mean if you take one centimeter cube of gas here, there are, I mean I think 10 power 20 atoms, molecules, but still, so one question is, can you apply MHD models? So, MHD models requires that. So, remember I made one remark that you need continuum approximation. So, what is continuum approximation? That the mean free path length is much smaller than the system size. Then only we can ignore these collisions. Now, for the solar wind, the mean free path length is, I mean in the interaction is, there is something called 1 AU, astronomical unit. So, distance from the Sun to Earth is called 1 AU. So, one collision is rarefied when it on the average from Sun to Earth, it hardly collides. But still, if you look at the probability distribution function, is not too far away from Maxwellian. So, if you look at, so this way to check whether it is thermalized. So, what is Maxwellian distribution? We have this Gaussian distribution, the VRMS, no? So, how does it become Maxwellian if it is not colliding? So, reason it is becomes Maxwellian, I think I agree with this, but mostly argued by researchers. There is ambient magnetic field. So, the ambient magnetic field acts like a scatterer, it is a random magnetic field. So, that is scattering, you do not require a magnetic field to scatter. Just imagine that there is an electron which is going in a magnetic field and per turbulent magnetic field, you do not need another electron to scatter, it is a magnetic field will scatter, and if it is turbulent then it can make it Maxwellian. Stop. Okay. Okay. So, this is what will make it Maxwellian. So, we see this solar wind. This is paper by Tu and Marsh, I think in 1991. This is a paper by Goldstein and Matthews and Goldstein. Goldstein 1982. So, all of them show 5/3 to good approximation. So, these lines are 5/3 lines spectrum. So, this line, okay, I didn't draw it properly. So, these are okay. So, there's so spacecrafts have been sent. So, there are spacecrafts like Voyager, Pioneer, sent way back in 60s, 70s, 1970s, and they collect data. So, what do they do? They put a probe. So, they are just going in the free space, outer space, and they have probe which measures magnetic field, speeds, temperature, and so on. And but the speed of the probe is much smaller compared to 500 km per second. So, you can use Taylor approximation, Taylor hypothesis, according to which if I am stationary here, the wind is blowing, then you can treat as if the wind is stationary and I am scanning along a line. So, you need to convert the frequency spectrum to wave number spectrum. I made this remark before, no? So, you can convert EF, which is what is measured by the spacecraft, EF, you can make it to convert to E of k, and these are E of f, not E of k, but using this Taylor hypothesis we make this conversion, and they show reasonable convergence with 5/3, though 5a3 and 3f are very close. The difference is 0.16, and there are enough error bars, so people can get. I mean, if a believer, then you say, well, I don't believe you. So you can, because the error bars are when the difference is too small. Okay, so but this has been reported many years. So, in fact, Creighton was believed, but you see, the solar wind was saying that it is not. Numerical simulations. People have measured this, especially after 2000 spectrum, but this may be not very clearly visible, but this is -3/2 theory by Bolderev. This is by Biscamp. He believes is 5/3 line, but these lines are not very. This is by Bereshniak and Lizarian. And these are not very convincing either way. So, these 3/2, 5/3, 5/3, and now so what we did was we said, well, let us look at indirect predictions. Indirect prediction was look at this pi plus and pi minus. So, this we wrote in 1996. See this pi plus and pi minus when E plus and E minus are unequal. This is a way to test, no? If E plus and E minus, in fact the ratio is roughly 10, and you look at pi plus and pi minus, if they are equal, then Creighton is right. If they are unequal, then Kolmogorov theory should work, and we found that Kolmogorov works better. Okay, so Kolmogorov works better. This is 1996. So these are indirect proofs which are more convincing than trying to fit a line with this 5/3 or 3/2. Now, I think more convincing will be this B naught effect, whether we can show that this alpha n wave scattering is by B naught, and there are ways to do it, but nobody has done it so far. Okay, thank you.